Welcome friends. In today's video we'll learn the steps required and involved in packaging an app for Kubernetes. Okay. So there are basically two steps. First is wrapping the application in a pod. Well, it is also a two-step process. First wrapping your application in a container and then wrapping it into pod. But yeah, basically you need to wrap it up in a pod. We learn in this video what is a pod as well. Second is deploying it via a manifest file. So we'll understand what is a manifest file in a lot more detail, what is its use and what is its significance. Okay. So let's start step by step. Suppose you build an app. You write your code in maybe Java or you write it in C#. You write your code, you develop it, you test it. After that, what you will do? You will build your app in a container or containerize your app. You will, wrap it up in a container so that it is runs in a container is like an individual computer in which the app runs. So you will containerize your app. The most commonly technology used for containerizing is Docker. So you will containerize your app. Then you will store this image, container image in an image registry. Okay, once you have done this, then you can say that our app is containerized. So the commonly used image registries are Docker Hub or Amazon Container Registry provided by AWS. Okay, so till this step, you have containerized your app. Now comes the Kubernetes step. So you will define a Kubernetes pod to run your containerized app. Okay, so this is where, Kubernetes starts coming into picture. So what is a pod? A pod is basically a wrapper to run your containers on Kubernetes. So once you have wrapped your container into a pod, you can run it statically. So you can simply run it. But the preferred way is you deploy this pod using the controllers which the API server has provided. If you don't know what is the API server, please watch our previous video in this series. And then you will understand what is a control plane, what is a worker nodes, and the API server is part of the control plane. Okay. So the best way is to deploy using containers which are there in the control plane. Okay. So there are many controllers available. The simplest one and the most widely used is the deployment controller. So let's take an example of the deployment controller. So you deploy your app using the deployment controller. Okay. So what benefit does it give? Why don't you deploy your app statically? What benefit it gives for using these controllers? Well, if you particularly use the deployment controller, you get the benefits like scalability, auto upscaling, downscaling. We have talked many times. You can watch our previous videos. You got the benefit self-healing. Again, we have talked about this many times. But basically, if an error happens, it is able to heal itself. And you get rolling updates. Basically means that without any downtime, you can, update the version of your app. So these benefits you get if you deploy using the deployment controller. Okay. So suppose you decide that, yes, okay, fine. I want to deploy using the deployment controller, or I want to deploy using control plane, API server and controllers. So you have to write a manifest file. This is a very important file in Kubernetes. Let's start to understand why is it so important. So in this manifest file, since you have chosen to deploy with the deployment controller, you define a deployment. And in this deployment, you add some details like how many replicas do I want? How do I prefer to update my app? What should be the way to update my app and other details? Many other details go, but in an overview, these are some common details you specify in this deployment section of your manifest file. And then what you do, you use the AWS CLI tool. Going further in this series, we will do practical examples as well. But before doing practicals, let's understand the theory. So you will use the AWS CLI tool and then you will post this manifest file to the API server. Okay. And then you can sit and relax. Why? Because Kubernetes will take care of deploying it and monitoring it so that it continues to run absolutely fine always. Okay. So this is the structure. You code your app and then you along with your app and dependencies, you create a container. So the container contains your app and dependencies as well. And then you wrap your container in a pod. Okay. So the pod is the atomic unit in Kubernetes, which it can start, stop, create more, destroy, everything what it can do is a pod. So it is an atomic unit of scheduling for Kubernetes. So you wrap your container in a pod. And then comes the third step. You wrap your pod in a deployment. Okay. So you can deploy this pod as well, but why do you wrap your pod in a deployment? Because it gives many benefits like scaling, self-healing, and zero downtime updates. This is why you use a deployment controller. Okay. So Kubernetes follows a declarative model for configuration. Okay. So let's understand what is a declarative model. So in a declarative model, there is an important point also, which is called desired state. We'll learn both of this. So this declarative model and this desired state is the, you can say heart of Kubernetes. This is the core design consideration that has been taken in Kubernetes. Okay. So suppose you want to configure your app. What steps will you take? First of all, you will declare the desired state in the manifest file. Desired state is just like, how many instances my app should run, and, in case of increased traffic, up to how many instances it should go, and then it should go down as well, when the traffic has reduced, and then, how to do updates in the app, and lot of configurations. How your app should behave on Kubernetes, you define as a desired state in your manifest file. Okay. And then you post this manifest file to the API server. So what Kubernetes does, it stores this configuration in the Kubernetes cluster store as a desired state of your application. This is how your application should generally be when it is running. So it is your desired state of our application. So Kubernetes stores your desired state in the cluster store. Okay. If you don't know what is a cluster store, please watch the previous videos. And then, Kubernetes implements the desired state. So it assigns tasks to the worker node so that what you want is achieved. It does things to make your app up and running according to the desired state that you have mentioned. Okay. So the various controllers in Kubernetes make sure that your observed state, which is the current state of your application, is matching with the desired state. Okay. And if it is not matching, they will do some things to make it matching. Okay. So you'll continuously monitor your app as well. Okay. So let's understand what is a manifest file. So a manifest file is written in YML format. Okay. And again, as we said, the concept of desired state, it specifies what your app should look like when it is running in a happy case. Okay. So this is called the desired state. Okay. For example, which images should it use? Okay. How many replicas it should have, which ports it should update, how version updates should happen for this app. All these details and many more details are specified as part of the desired state. Okay. So Kubernetes provides a CLI utility, command line interface utility. Okay. Which is called kubectl. Okay. So you use this kubectl to send the manifest file to the API server, which is part of the control plane of Kubernetes. Okay. So it is sent using the HTTPS protocol. Okay. So what happens when you send your file to the API server? Okay. First of all, your sending is authenticated and authorized, whether you are allowed to send or not. Once it has decided that yes, you are allowed to send, then it inspects the manifest file, and then it identifies which controller you want to use. For example, suppose we want to use the deployment controller. Okay. Then it records the desired state in the cluster store. Already we talked about this. And then it gives workers some tasks to do. So it schedules worker nodes, and then these worker nodes do some tasks. For example, they pull the images, Then once they've pulled, they start the containers. Then they attach your application to the networks. Then they start your application process. Okay. And then they continuously run a reconciliation loop. This loop is the same thing that we talked about, that whether the observed state is matching with the desired state or not. If it is not matching, they will do the needful to make it matching. That is the beauty of Kubernetes. You don't have to hire a person to continuously monitor the running of your app, whether it is running fine or not. Kubernetes takes care of this for you. So this desired state model is quite opposite of the imperative model of app deployment, where people used to maintain long scripts, and these scripts for platform software, for testing environment, for staging environment, whether it is Windows or whether it is Linux, based on the operating system as well. And then people used to build and continuously monitor the running of your application. So this was the imperative way of managing applications. But then Kubernetes came with this beautiful declarative model. So it is, lot simpler. It provides self-healing. We talked about this. It provides scaling. It is version controllable as well. So you can maintain your manifest file in your code repository only. And then you can manage changes to your manifest file using any standard version control like Git. Okay. And it is, self-documented. So in your code only, in the manifest file, you have specified how your application should run in the production environment. So any new developer who joins the team, if he goes through the manifest file, apart from the code, he also understands what are the requirements for this application to run. So it understands all its dependencies and all its requirements, and how the application will run or production, how it will behave, how it will scale up, how it will scale down, how it will be updated. All these things about the application running behavior, the developer can come to know by the code itself, because the manifest file is present in the version control in the code itself. So this is the declarative model. It is, a next level to the old imperative model. So the declarative model is based on how things should look in a happy case. So suppose, for example, you defined a desired state in your manifest file. You specified that it should run on 10 replicas or 10 nodes or 10 worker nodes. It should run using 10 instances. And for example, 2 of the nodes fail. The Kubernetes controller will observe it. It is also called reconciliation loop, or you can say controllers as well. So they will observe it. And then they will start 2 new replicas in order to make the desired state. So from 8, it will again take the running nodes to 10, because you have specified it in your desired state. And now suppose in production you were running version 2.0.0, and now you want to update your app to 2.0.1, a slight minor update. Okay, so you will post the updated manifest file to the API server, and the relevant controller responsible for doing this change will notice it. And then it will update all the 10 replicas, and it is capable of doing it one by one, so that this deployment doesn't require a downtime. So it will keep increasing the 2.0.1 replicas one by one, and keep decreasing a 2.0.0 replicas one by one, so that it is a zero downtime update. Okay. So you tell Kubernetes what desired state should look like, and Kubernetes does the hard work to achieve your desired state. So earlier we had virtual machines. Then we went to containers, and now we have reached pod. So earlier virtual machines used to be the unit of scheduling. Then containers were the unit of scheduling, and now pods were, or Kubernetes pods are the unit of scheduling. So how did the name pod came from? So pod means a group of whales. A group of whales, in English we say pod of whales. Okay. And if you must have seen the Docker logo, it signifies a whale. So in a way, pod means a group of Docker containers, or any containers, a group of containers. That is why, this name was chosen to signify a group. Okay. So in a simple model where you are deploying your app using Kubernetes, in a simple model, every container should have its own individual pod. Okay. So every container should run in its own pod. But there are some advanced cases as well. In these cases, multiple containers run on a single pod. Example of this are service mesh. We have a microservices series as well in our channel, where we are planning to create a video on service mesh as well. So stay tuned there as well. So the example is a service mesh. Then you can have a web application container and a helper container running tightly coupled with your web application. This is also an example of multiple containers in a single pod. And a more simpler example is you have a container where an application is running, and there is another container which is logging every minute details happening in that container. So you can say it as a log scraper. In that case, also you can have more than one containers running in a pod. Okay. So in this diagram also we can see that there is a main container and then there are some supporting containers. Okay. All wrapped in a pod. So this is, a more advanced case. An important thing to note is the pods actually don't run your application. Okay. Who runs your application? The container runs your application always. The pods just give an execution environment for your containers to run. Okay. And in case you are wrapping multiple containers in a pod, in that case, all of the containers share the same execution environment. Okay. So what will they share? They will share the same network. They will share the same volume. They will share the same IPC namespace. They will share the same shared memory. These things, multiple containers running in a pod will share with them. And they will have the same IP address as well, because they are all running in the same container. And they can, talk to each other using a local host interface. So they don't need to go to the API server to communicate with the another container, because they are running in the same pod. They can simply communicate to each other using the local host and web address. So multi-container pods are tightly coupled containers. Okay. They share the same memory storage. So generally, if we don't need containers to share the same memory and storage, if we don't need, we should run single container pods. Every container should have its own pod. Okay. This makes them loosely coupled, so you can manage each of them individually. According to individual traffic, you can upscale, downscale, manage their updates, do various things individually. Instead of, tightly coupling them, then you cannot manage them. Okay. This creates a problem as well. There is lot of unencrypted east-west traffic going through between pods because they are loosely coupled. So, as I mentioned earlier as well, a service mesh helps you secure this traffic as well. We'll create a video on service mesh as well. So please subscribe to our microservices playlist and stay tuned there as well. Okay. So now a Kubernetes pod is a minimum unit of scheduling in Kubernetes. Kubernetes cannot go below a pod or inside a pod and do some things. Okay. If you want to scale your app, you have to add or remove pods. If you want to scale up, you have to add pods. If you want to scale down, you have to remove pods. But you cannot go inside a pod and add more containers to an existing pod. Kubernetes cannot go inside a pod and do something. This is not allowed. If you see this figure, here we are trying to add more containers in a pod. This is not at all allowed. What is allowed is you can create more pods with the same application, more pods with the same container. This is absolutely allowed, because a pod is a minimum unit with which Kubernetes deals. And whenever we deploy a pod, it is an atomic operation. Okay. You cannot, stop it in between. Either it gets deployed as yes or no. And the entire pod gets deployed. If you're using a multi-container pod, all its containers would get deployed and then they will start and be serviceable. Otherwise, they will not be serviceable. So it is not like if you are using a multi-container pod, 2 containers are ready, but 2 are not ready. This will not happen. Either all of them will be ready or none of them will be ready. So that is why I highlight that deployment of a pod is an atomic operation. Atomic means 0 or 1. Nothing like 0. 0.5, 0. 0.7, 0. 0.9 and then 1. No. Either 0 or 1. So in layman terms, if we want to understand pod life cycles, we can, understand in a layman way that they get created, then they live, means they continue to service or run, and then they die. Okay. But it will never happen that after dying, they again are brought back to life. This will never happen. What will happen is a new pod will be created. If they die and you still want your application to be running, a new pod will be created. It will be exactly similar to the previous pod, but it will not be the previous pod. That is dead. It cannot be brought back to life. So it is not same, similar but not same. It will have a new ID. It will have a new IP address. Okay. So this nature of pods you need to keep in mind when you are designing your applications. Okay. You should remember that your pods will be loosely coupled with the actual instance of worker node where they are running. They will be loosely coupled. They can be running on node 1 or node 5 or node 10, anywhere in the cluster irrespectively. So they will be loosely coupled to the instance of execution. And if they fail, a new pod will be started anywhere else in the cluster. Okay. So you need to keep these things in mind when designing your application. You cannot design your application assuming that things will never fail. While designing, you have to make this consideration, what will happen when things fail. So you have to understand this basic nature of pods while designing your app. Okay. Another characteristic of the pods is pods are immutable. So once a pod has been started, you cannot change anything in that pod. And if you try to, SSH into the pod and try to change some configuration, that is a bad practice. You should never do it. Why? Because that change is temporary. If you change anything in that pod, and suppose if that pod crashes and in its place a new pod started, it will not have the change that you made specifically by logging into the pod. So this is a bad practice of making change. Instead, you should post your changed manifest file to the API server. It will delete the old pod. It will create a new pod with your updated configuration. This is the correct way of updating your pods. Okay. So they are immutable. You cannot change them while running. As we already said, the best way for deploying pods is using the controllers which are available in the control panel. You should use controllers. Some example of the controllers is deployment controllers. We've already talked about this. Daemon sets, stateful sets. There are other containers as well. We'll learn each of them one by one. So let's talk about the simplest controller, which is the deployment controller. So it is a higher level Kubernetes object. Okay. As we showed earlier in the diagram as well, it wraps around a pod. Okay. And it provides additional features like self-healing, scaling, rolling rollouts, and version rollback as well. So if you updated your version to 0.2.0.1 and you see if something is not working, you simply update your manifest file to 0.2 version 2.0.0. You post it back to the API server. So, and Kubernetes will move the running version of your app from 2.0.1 to 2.0.0 one by one for each pod without any downtime as well. Okay. So this is, you can do a graceful rollback as well. But another thing to remember about pod is that they are unreliable. Suppose you are doing a video rendering operation in your application, and video rendering generally takes a lot of time. And in the midway only that pod fails. What will you do? You obviously the reconciliation loop will replace the old pod with new one on failure. So what will happen to the processing that was midway in the old pod? So you need to be aware of this characteristic of the pod. They are unstable. They can go down. New pod can come up. If there is a traffic increase, again new pods will be added. If the traffic has decreased, some of the pods will be killed. And if you are again updating your app version, again the existing pods will be killed and new pods will be started in its place. So this basic nature of the pod, that they are unreliable, you need to consider while designing your application. Okay, so to mitigate this unreliable nature of the Kubernetes pods, we have services in Kubernetes. So services provide a reliable network for your set of pods. For example, we talked about video rendering application. So we can see here that we have two instances running. A service will sit in between your video rendering application, and maybe you have an uploader which is trying to upload videos to your video rendering application. So a service will sit between these two applications. This application will talk to the service, and service will talk to the video rendering application. So this way the uploader always talks to a service, and service talks to your video rendering application. What will happen? What are the benefits of using a service? That there is a reliable name for the service, and there is a reliable IP address for the service, because we learned that pods are unreliable. They can die, new pods can come in their place. So if your video uploading application talks to the pod directly, in midway of this upload process only a pod can die. What will happen? New pods can come into its place. But if your application is talking to the service, and then service is talking to the pod, service will take care to distribute the load between pods. So it will do the load balancing between pods. So you never have to talk to the pod directly, because they are transient. They can come and go. But service will always live. It has a stable name. It has a stable IP, which your calling application, which is the uploader in this case, can communicate with. So it provides a stable DNS name, a stable IP address, a stable port, which the client application can integrate with. Okay. So pods will come and go, but service will keep on observing them. Which one has gone, which one has come new. It will register the new ones with itself and remove the reference of old ones. So in a way, we can say that it provides a stable network abstraction point. Abstraction is a very important concept in computer science generally. So it provides a stable network abstraction point for the calling applications. And another thing to remember about services is they don't possess any application level intelligence. They don't know about your application. So any application layer information, example host, path routing, it will not at all be aware about our application. It will just know that some pods have come and some pods have gone. What is running inside this pod, it will not be able to know about the application level knowledge. So friends, in this video we learned about what is a pod, what are the characteristics of the pod, what are controllers, especially the deployment controller, what is a manifest file, and what are services as well. So we'll continue to build upon this knowledge and take you more deeper and deeper into Kubernetes. We'll do some practical examples as well. So I request you to please show your love by liking this video, sharing it as much as you can on your different social medias, and subscribing to our channel, and don't forget to hit the bell icon as well. Thanks a lot for giving us your time, showing us your love and support. I read all the comments that you write in the comment section. So please let me know, how did you feel about this video, whether you liked it, or if you want me to do some changes. I will really appreciate your feedback. So please post in the comment section as well, and please show your support and love by liking this video and subscribing to our channel. Thank you.